Hello! So it's time to use that rock kit that you got with the textbook through Inclusive Access. I need you to get it out and I need you to follow along with me, even though it may seem a bit simplistic. This will help you, I promise. My goal is to make these labs easier and more enjoyable for you because typically they can be frustrating if you don't have everything you need or maybe are not sure what you're supposed to use. And these videos will help you resolve that. So this first one I'm going to do for minerals will be longer than the rest of them that are your identification labs because I'm going to give you that overview. So get it out, and the first thing you're going to want to do is check the upper left-hand corner and make sure that you have a sticker that says fall semester for the rock box from Environmental Geologic Solutions. If for some reason yours says summer, there may have been one or two that actually got the wrong sticker on, and there's a way to figure that out. If you are in that situation, you need to contact me immediately by text and phone and email. All right, open it up and get out the bag that says Lab 4. And Lab 4 should have 10 samples. That's how you'll know if it is indeed the fall kit. And you will also see a yellow insert that says fall semester. Once you've done that, you will see that there's a total of 5 larger bags in your box. Lab 4, which is minerals, Lab 5, which is igneous, Lab 7, which is sedimentary rocks, Lab 8, which is metamorphic rocks, and then Lab 10, which is fossils. Then you'll have a small little plastic bag that contains some testing items. Look for a penny, look for a steel nail that you'd hammer into the wall, and 2 little square plates. One's glass and one's a white porcelain plate, and a little magnet of some sort, and you'll know you've got the right things. So when you do that, you pull out your bags. They're all individually labeled. What do I mean by that? We've taken a lot of time to make sure that these are easy to find. So you're going to pull out, for this lab you're doing now, this one right here, which says Minerals Lab, Lab 4. And this is what the bags look like for the rest of them. Here's that little testing kit. Your magnet might look slightly different. So when you get them out, you should have 10 samples in the Minerals Lab 4 bag. And I'm not saying this is the exact order that yours will be in. They could be different from semester to semester, and they are typically, like next fall might look a little different than this one. But you're going to line them up like this. Make sure you've got 1 through 10. What is not a good idea is to start lining them up, getting them out, and putting them on top of it. Now, obviously, this is not even the right lab, but you see how I just put a sample on top of all of these? And the reason is this. Many samples look very much alike, and minerals in particular can be that way. So imagine if you have a seismic moment at your house, not literally an earthquake, but let's say your dog or your cat, or if you got kids or a roommate, they come flying in where you're doing your lab, and poof, everything gets knocked off and flies across the room. You can have no idea which sample goes where. So your best bet is to take one out at a time. Do it and finish it, and then put it back in and pull the next one out. Do one at a time. Trust me on this, because once you get them out of order, that one's on you, because I've given you a heads up that you really need to do them one at a time. And you can see right here, here's some minerals, how similar they are. So just trust me on this. Do it one at a time. So you don't have this sample, but this would be a great example. There's other samples that could look like this. So this one is a good example to use. And since you don't have it in your box, I will tell you this is called hematite. And hematite is red. It's often a silver color as well, but it's what turns rocks a kind of a rust color, an iron color, because it is iron. That's exactly what it is. And so as hematite rust, it will. But one of the things important for every mineral and sample that you do for your identification labs, except for fossils, is that you use the equipment that was provided in your kit, meaning the little square plates, the steel nail, the penny, the magnet. And that's where this thing comes in. That's the little package I'm talking about. So it's time now to get out that bag called Lab 4 Mineral Samples. And then line your bags up 1 through 10, but pick out bag number 1. And you're going to take that sample out. Now I'm going to show you a little bit about using the testing equipment and give you some pointers, because this is likely your first encounter with using all of these tools. The key is to use them for each and every sample the same way. So the white street plate that you have, mine has stuff on it, little streak marks, because I've been using it. But the mineral I just showed you that was hematite actually produced this streak on that plate. I took it and I just took the sample. If this would have been, let's say, the sample that I just showed you, I would have done this action right here, just done that. And you may not see a color. If that's the case, it's a white streak or a colorless streak. You're gonna, in a minute, find out where to go for that information. Once you've done that, you're gonna take it and always test for a magnet. Now you can see my magnet's picking this up. You may have a different magnet that's not this shape. It just doesn't really matter what magnet you have in there. But I'm gonna put it on here and see if it sticks, and it does not. But you can see clearly it's holding the nail. So that leaves me with these 2 testing items right here, a nail and a glass plate. All right, so there's 2 ways to test for hardness on a mineral. One is you take a nail and you really dig in like that. None of this action right here. That's not going to cut it, okay? The other option is you take the mineral itself or the rock and you scratch it. I mean, none of this action, that ain't going to do anything. So you got to really take it, and then you're going to brush off all of the residue, whether it's on your rock or here, depending on what you used. If you used the nail on the sample or you used the nail on, or the sample to the plate. Either way, you got to dust off that material and you're looking for an indentation. So this is where people often get it wrong. They think because there's a residue that one thing is harder than the other. And typically they're thinking that the glass plate is harder than the sample. It might be vice versa. That's why you wipe away the residue that's created when you put the 2 things together, and you feel and you look for an indentation. A really great thing to keep handy is a magnifying glass. Those of us in geology and in gemology have a little hand lens that we can use to do that. You can take a regular hand magnifier, maybe have a magnifier glass with a light that you use if you do any kind of tool work. I have those, they're wonderful. Get a bright light out and you can really see where the indentions are on your sample and or the glass plate. So that's the key things that you're going to do. Now there's one more thing that I couldn't include in your kit. This is showing you that hardness, by the way. Oh, I left an important thing out. We didn't talk about the penny. So in your textbook in chapter 4, section 4, there's a list in the text that tells you the approximate hardness of something like a steel nail, the glass plate, and the penny. And the penny is about a 3. So if the penny doesn't scratch the sample, but your steel nail does, that's harder, then you know it's between that and like a 6 or 6.5. And let's say the mineral successfully can be scratched by both of those things, then you've kind of ruled it out that it's got to be higher than the glass plate hardness. And in this particular case, it didn't get scratched, meaning the mineral did not scratch something. So you would need to find out more about the mineral. I'm going to show you where to do that. The streaking is pretty darn easy. You just take the mineral. Here's on the left, you'll see there's no streak because I haven't conducted it yet. Then I took the mineral and I streaked it against the plate. And then you can see right where the nail's pointing to, right in here, that's the color it left behind. Not all minerals leave the color that you may visually see. As mentioned earlier, many of them will have what's called a colorless or a white streak. And you're like, well, what good is that going to do me on this white plate? So you can buy a black plate. They're expensive, really expensive actually, and they're kind of hard to come by. So that's why you don't have one in your kit. It just would have continually driven the price up for not much reason. But that's how we determine a streak for those particular minerals and rocks that have no color, meaning no streak color. But some streaks colors are distinctive and unique to that particular mineral, making the streak very important as a way to kind of rule out what you've got. Now, you don't have this in your kit. The reason is it's diluted hydrochloric acid. I couldn't have provided that for you in your kit. A lot of challenges to deal with when you start handling hazardous chemicals. So what I'm going to suggest is if you want the fun of doing what this would do, which is create a fizz when calcite is present, then take a bottle of vinegar, put it in a, get yourself a little dropper like this, or if you have an old dropper from medicine, clean it out real well and put the vinegar in, and it pretty much does the trick. And that's so much fun. So this is what happens. So here's a piece of calcite right here. And can you see where I added the acid and it went psss? It actually makes a reaction. Just an FYI, that's what happens to rocks that contain calcite, specifically something like limestone. So when you're dealing with something that reacts, all it means is calcite is present. It doesn't trump it as being something like limestone, often it is, but it just tells you that there's calcite in it. So you can see the same reaction if you take something like an Alka-Seltzer and drop it in water. Effervescence is what that's called. So that fizz is a very important clue. So all we're doing in this process is collecting data, clues, and we're going to put that information together, and then we can actually do a pretty good job of identifying what you got in your box. All right, so remember there are 5 identification labs this semester, and we're going to start with lab 4. So you need to put the rest in your box. We're only dealing with the lab 4 mineral samples for this particular lab. So there will be 10 samples in your box for that lab, meaning in the bag lab 4 minerals. And then there'll be 15 more samples for a total of 25. You're like, well, where are the other 15? I provide you pictures, data, and walk you through it. For just a second, I'm going to show you how to find information. Type in geology.com. There's a link in your lab folder for each identification lab. And as you do these labs, you can use the rocks or minerals. Now, fossils, I provide you a different identification chart. So we're going to start with minerals. Okay, just skip this and say close. Something new. And then let's say I wanted, since I mentioned hematite, let's go take a peek at it. So you keep scrolling down. Oh, here it is right here, hematite. All right. Well, most hematite is red or has a silvery red color because of the iron that's in there. If you'll scroll down, you'll see some physical properties of the mineral, some various pictures and so forth. But some of these are pretty good pictures. So a lot of these samples are just normal, everyday samples that you would find in nature. And notice it tells you what the chemical classification is. It tells you the color that you may see visually. the streak color, and notice it was red to reddish brown, which is exactly what we saw when I streaked that against the porcelain plate and you saw that reddish color. Its luster is metallic, submetallic, and earthy. So if you want to learn more about luster, just do some research on these. Type in luster, earthy, and read about what those are. And some of this stuff you really don't need, but getting down here to Mohs hardness, you do. So the Mohs hardness is about how hard it is. Sometimes it can be a range. And that may seem like, oh, it has to be one thing. No, not necessarily. It depends on how this thing was made in the environment. So this one's a 5 to a 6.5. The specific gravity is really about how dense it is in relationship to water. And then you can see a little bit more information and then something about its uses. Sometimes I give you some more clues about it in terms of special properties it might have. Maybe it fizzes because of acid, or maybe it smells funny. Maybe it fluoresces under a black light. Maybe it is magnetized. All of those things could be. So that's where you're going to find your information. Just to recap, type in geology.com in your lab folders, 1 through the first 4 that you'll use for your identification lab, meaning lab 4, 5, 7, and 8. You will be using geology.com. All right, we're to the point where you need to have gotten out your first sample, number 1. Remember, you have all your bags lined up, but you're only going to get out 1 sample and set it on that bag at a time. I recommend getting a paper towel out so that you can sample along the way and clean your stuff up. Everything is a nice orderly type situation. And when you get that sample 1 out, the first thing you're going to do is put a magnet on it. So I've tested this, and I'm testing it right now on my desk, and the magnet isn't sticking. So this clue, no, it's not magnetized. The next one would be take that mineral and just across that streak plate. And that's an important thing to do. So when you do that, remember, a nice firm thing, and then wipe off the residue. There's nothing there. So that matches what I'm giving you here. It's colorless. Another thing I'm going to ask you to do, I know it's a little weird, so if you feel uncomfortable, do this, put it back. If you don't taste anything in particular, like it's not bitter, it's not salty, that helps limit the scope of the particular minerals that do have a taste. Then you're going to take this mineral and you're going to get out this and this. Okay, so you're getting out your glass plate and this. And take this mineral, but depending on the edges that you have may dictate whether or not the glass plate works very well. And I mean, you're going to really dig, not this kind of action. Okay, and I'm doing it's leaving us a mark. But the best thing to do is probably take this and really dig and then remove any dust or residue. And the nail could not indeed scratch it. That's a very important characteristic. That means it's harder than the nail. In fact, you're seeing the listed hardness here as 9. So to help you throughout the lab, I want you to get the Mohs hardness scale out that's in your book and reference it the whole time, because I promise you everything could be on your lab somewhere. I said could be for the Mohs hardness scale. Now, 9s are not always called this. When you look it up, there's lots of different types of them. For example, rubies and sapphires, they're examples of this particular type of generic name for a 9 on the Mohs hardness scale. But the sample you have is not gemstone quality. Okay, it's just what this is as a 9. All right, so get that back in your bag, seal it up, put it away. Get out your next one, and we'll move to sample 2. Now, don't be deceived if sample 2 is kind of glassy. It's okay. If it's not, it's okay. This particular mineral comes in a lot of different shapes. Sometimes they've been tumbled, and a lot of your samples have been tumbled. And so they may be kind of smooth. But we go through the same process. Oh, we didn't test for acid on the last one. So if you've got acids, go ahead and squeeze it on it, get it back out, and then let it dry and blot it off. And you do the same thing here. I didn't have a reaction to it. And when you do the acid test, folks, with vinegar, don't douse it. Just a little bit's all you need. You'll see the reactions when it happens. Now, do the taste test to it. Did it taste funny? No, this one shouldn't, but you'll know if it does, I promise. All right, the color. What do you visually see? And folks, color's like the worst way to identify almost all minerals, not that are common anyway. And only a few that are common are really good in terms of identification with color. This is not one of those because it comes under every color in the rainbow. Now, its luster is vitreous. What does that mean? It kind of means it has a potential glassy look to it. It can. And so many minerals have this, and maybe more than one type of luster. So if you don't know what a luster means, just do a Google search for it and you can find out. So take the nail in your glass plate. Oh, did you streak it to see that it had a colorless streak? Because I sure couldn't get a straight color out of it. And you're going to do the same thing. You're going to scrape that mineral across here, and it will leave a line, like an indentation, provided you get a good edge to it. And then you're going to take this and scratch it hard against the surface of that mineral. And it should leave a indentation. So wipe away the residue and you'll see that. This is what I call a reference mineral. And kind of the 3, which is calcite, and 7, which is this one, are really good indexes in terms of reference minerals for using them against other minerals as you have them in your kit or in a lab or in nature. Like I carry this mineral with me out in the field to do tests with because it's so common. So put number 2 back in its bag. And you're like, well, hey, I still didn't figure out what it was. Remember, you have a list of minerals in your book. Now, there was a couple of minerals or 1 or 2 that you needed to add that were in the instructions for the lab that I put in Brightspace. Make sure you check that every time you have a lab if there's an addition that you need to do. This was not an addition. It was in the original list. All right, let's get out sample 3. All right, the first thing you're going to do is you're going to put that magnet on. I'm not seeing it sticking. Okay, so that's not magnetized. I'm going to take it and I'm going to do this. It didn't do diddly squat, so I couldn't see anything. All right, remember I always told you to do the old, this one has a taste, very distinctive taste. Can you tell me what that taste is? Okay. All right, the next thing you're going to do is you are going to take this and you're going to try to scratch it against this. Can't make a dent. And then I'm going to take this, and the reason it can't make a dent, folks, is because this is much softer than the glass. And then I take the nail and I scratch it, and the nail is going to, oh man, it put a big old dent in it. Not only did it break it, I mean, I'm seeing a dent. Wipe away the edge there, and I can totally see the residue when it's gone. I can see I've left a dent behind. So the really big clue in this one, also test it. I'm testing it right now. Nope, it's not reacting to acid. I'm gonna wipe it off. The big test here, that it has a taste. It tastes just like salt, and it's because it is. Whew, I need to get something to drink. Not a good idea to keep beverages handy when you're working with acid. So I'm going to tell you that's not scientific practice. All right. Look at your list in your book, and you should be able to figure out exactly what this is. Okay. Sample 4. Before I go any further, if you're like, I'm lost, then I'm going to tell you to stop. And I'm going to tell you to go to the page in your book in section chapter 4 that's in the lab and look at all the minerals that are listed there and add the ones that need to be added. And then you're going to go to that geology.com website and gather the information, like its hardness, its color, its streak, if there are any special properties, and that should make this lab go really much faster. It applies to all of the identification labs. All right, number 4. When you get out number 4, looks very similar to number 3. All right. In this particular case, let's put the magnet on. Oh, didn't stick, it's not magnetized. I am going to go ahead and do this test. Nope, no taste, just tastes like dirt. And then I'm going to do it against here. It didn't have, maybe a little white, but you can't see it. I do have a black street plate, and indeed it turned out to be a white color. And then I'm going to take the nail. Oh man, it left a big old Grand Canyon. And I'm going to test this against the glass plate. I mean, it does nada because this thing is much softer than that, but much softer than the nail. That's why the nail could scratch it. I'm going to test it with acid because this really could be calcite, okay? So when I squeeze this stuff on there, it does not work. So another cool thing, this is where on things that we know are really soft, when you start to be able to try to scratch it with your penny, I would use the penny too. And this is scratched by the penny. At that point, I would take my fingernail, and you likely can scratch this. So what's a 2 on the Mohs hardness scale? That's what this is. Super common. It's used in a lot of drywall, wallboard. It's used in plaster and some other things. So it's a super common mineral, and you should figure out what that is by now. All right, so put that one up after you blotted it from the acid, if you have that, and get out the next sample, number 5. Okay. So this is more in the rock form that this mineral comes in. And as I feel it, sometimes it can feel like soap, not always. As a matter of fact, this sample is sold as something called soap stone. So as you do it, same routine. Nope, didn't stick. Okay, well, let's do this. It was streaking. Mine didn't really streak pale green, a little, but mainly whitish color. And I also have a black plate, so I can see it better than you can. Then I'm going to do the hardness test. Okay, I didn't do anything to the glass because it's much softer. And so we automatically know that this is going to scratch it. Okay, it did. I can really get a good look at my fingernail. It's scratching it too. I'm going to do the taste test. Doesn't have any funny taste. You do an acid test. It didn't react. Blot that off. Well, the other one was a 2 that we just had for sample 4. This one is a 1. So what's a 1 on the Mohs hardness scale? That's what you got, okay? Well, that brings us to sample 6. And when you get sample 6 out, first thing you want to do is put the magnet on it. I didn't get it to stick. Then I would do the old test. Nope, I didn't get any taste there. Then I would take it and I would put it against this. It didn't have any color when you streaked it, so that matches. Then we're going to do the old scratch test. So start with that glass plate, and I mean really dig, wipe away any residue. This one for sure should have, indeed, scratch that. Test this little puppy against it. And this one's going to lose because it's not as hard. Penny is so much softer than this mineral because we know it has a hardness of 8. So you can look at your Mohs hardness scale and figure out what this is. Your sample color might have been different from mine. Mine kind of had a yellowy kind of clear look to it. But this one is and can be a gemstone. So thinking about that, what do you have? Once you've cleaned it up, put it away. Let's move on to sample 7. And this one's important. So when you get it out, first thing I want you to do, regardless of what color, mine's kind of an orange, you may have a green, a yellow, blue, white, clear, it doesn't matter, but most of them have like a lacquer on the outside simply because that's how they were purchased. I can't get the magnet, so I'm going to do the taste test. Doesn't have any interesting taste. So I'm going to take this and streak it against this. Didn't make a color, even though mine's kind of an orangey color. So I'm going to take the glass plate. Oh man, this thing did not leave. I mean, matter of fact, there's just residue everywhere. I wipe it away. Nothing's there. But I take the nail and I scratch it. Man, it leaves a Grand Canyon after I scratch that with it. Use my penny, this one might actually start to scratch. Well, it's kind of similar in hardness because this one sample happens to be a 3 on the Mohs hardness scale. So one thing we haven't done, get that acid out and let's test it. Fun, 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 fun. And look, it is fizzing. That's because it is a 3 on the Mohs hardness scale, and it's the only mineral that will fizz. You betcha. Look at the Mohs hardness scale. What is a 3? You figured it out. Blot that little baby up and let's put it up, pack it up, and get out sample 8. All right, my sample 8's kind of ugly. Yours might be too. It has a weird looking shape. And let's see. Okay, here we go. Looking at it. And then I'm going to do the magnet test. It didn't stick. Do the taste. Nope, no taste. Take it and didn't do it, but I have a black plate and I can tell you it made a white color. Then I'm going to take it against this glass plate. I didn't streak, but it left kind of a residue behind. I'm going to take the nail and do that against it. And boy, I could leave a Grand Canyon when I got the right edge. So we know this is harder. My penny didn't scratch it. So that kind of puts us between a 4 and a 5 because it can't be a 6 and it can't be a 3 because of the testing equipment. So I'm giving you the information. It's a 5 on the Mohs hardness scale, so check it out. What do you think it is? This is a really important mineral because it's found in lots of stuff. It makes a lot of our fertilizers. Some are pretty enough to actually be gemstone colors. All right, moving on. Let's get number 9. Oh, I know what that is. Well, humor me. Let's start with the magnet. It would stand to reason, since this has a metallic color, that it would stick up. It doesn't. And it's not going to because it's not going to have any lead in it. Well, get this trusty little streak plate out and let's see what happens. And I left a streak. I'm like, yes, I finally left a streak. And I wipe it away. It's kind of an ugly greenish black and brown color. So if this thing was officially gold, it would leave a golden yellow color, but it didn't. Also check out its hardness because this, see, can you scratch it? Just start scratching and see what happens against your nail, your penny, and your plate. And also feel for how dense it feels for its side. That's because it has a little bigger specific gravity as compared to the other samples you've had thus far. And specific gravity is a measure of how dense something is in relationship to water. All right. I think you know what that one is, right? All right, let's put it aside. And let's get to the number 10. We're not done though, remember? We still have 15 more to go. All right, you may have 1 or 2 in here because they're really tiny. Yours have been tumbled. So when you get it out, do the whole rigmarole. First of all, it's a halide. Mine are not sticking to this. It did a white streak on my black plate, but kind of hard to see on the white one. Then I want you to, didn't have a taste. It wasn't scratched by my steel nail, or it wouldn't scratch the glass plate, but it could scratch my penny. Interesting. And I bet you the sample that we had that was a 5 on the Mohs hardness scale would scratch this one. And anything higher than that would. And anything lower than what it is, which is a 4, wouldn't. So, it's a Mohs on the 4 on the Mohs hardness scale. So I have a cute story about this sample. I had a couple, one of the first years I was teaching, who were dating. And after the fall semester always starts right around, late August and early September. And that year, the holiday for Labor Day was early, and it was earlier in September. And we were just starting minerals, and they got engaged over the weekend. So we came in to lab, and she got the ingenious idea to take her testing equipment. You see where I'm going with this, and had to try to put a scratch to see if she had the real meal deal as a diamond, and it left a giant Grand Canyon. I looked at the guy and he was just heartsick, heartbroken, and I could see the fear of, oh my gosh, I just spent several $1,000s on a diamond ring and I was gypped. Well, she threw her stuff down, smashed it down, threw the ring at him, kind of shattered the stone on top of that because it's pretty soft as a 4. Never to be seen again in the class. He was just heartbroken. So I went with him to the store where he bought it, which was not a reputable place. So that's something to consider when you're buying rings, jewelry. And I was able to get him his money back. And he began to be consoled by a girl in his lab group who ultimately they started dating, got engaged. They invited me to their wedding and put a piece of this on top of their wedding cake because it was what brought them together. So what's a 4 on the Mohs hardness scale? And you'll guess it. So I know these are tiny samples, but this is actually somewhat of a valuable mineral. And these are tumbled versions of it. Sometimes in nature you'll find the crystalline versions and they're absolutely beautiful. Easy to see how it could be confused with some of your really rare diamonds that have the same colors that you can find, because this one comes in lots of different colors, not just the ones you have here. All right, so let's take a break, kind of get your stuff situated, put your bag up, and I'll see you back in a little bit, and I'll walk you through. You're doing a great job, so stick with it. Welcome back. So the rest of the lab's probably a lot easier, but you need to make sure you have gone through all of the minerals that are listed on the page for the mineral lab of the choices and have added any that I listed in the instructions in Brightspace, or else this part will seem more difficult to you. Because now we're looking at a bunch of minerals. Some may be duplicates of what we've already had. Many are new from the list. And it's okay if we don't use everything on the list, as the instructions say. So this particular mineral, if you've done your homework, it's pretty easy to tell. You probably even remember seeing a picture of it. But it looks like little books that you see right here. So it has excellent cleavage that you learned about in lecture. When you peel it apart, it makes an individual piece like this. Looks like laminate paper. By the way, this is a black straight plate right here that I set it on. And this one is a silicate mineral. It does streak white. You're like, well, how are you going to streak that? When they're in books like that, where they're thicker, you can actually do it. And it's pretty soft. So even your fingernails should scratch it. A penny should scratch it. So you don't even need to test it with a nail or against a glass, because you already know that you can scratch it with a penny in your fingernail. And its luster is pearly to vitreous, and it will not react to acid. The key is that it peels apart into layers. So if this thing's crushed up, it can be used in glittery makeup. So it makes the frosted appearance in like lipsticks, eyeshadows, nail polish. For example, my nails have glittery polish on them. That would be from this mineral right here. If you have a hot rod paint job on a motorcycle that's sparkly, it would be from this mineral. If you go to the Texas Capitol, it has been sandblasted with this. So smushed this mineral up and shot it onto the front of it to make it really, really shiny and glittery. So what is that? All right, let's move on to sample 12. Okie dokie, sample 12. Kind of looks like a piece of candy, doesn't it? It isn't, so don't try to bite it if you find one of these, because it could break a tooth. It is also a silicate in the major mineral group, and it will streak a colorless thing. So, but you look at it and you're like, that's kind of a blackish color. How does it do that? That's just a streak. There are other minerals that are black that do leave a darker color streak. And this thing can be a dark color, brown, black, even a dark greenish tint to it, often associated with mafic and ultramafic rocks. It can certainly be in felsic and intermediate. You're like, what is that? You'll find out in the next lab in section 5. Right now, we're just trying to learn about minerals. And it has a vitreous luster, and it has a hardness of 5 to 6. So you could probably scratch it with that nail. Well, what about the glass plate? But not at all with that penny. But you had topaz and you had corundum in your box. You could scratch this mineral with it because it has a 5 to a 6. Does it react? What mineral reacts? You already know this. It's calcite, right? All right. Check out that greenish color. All right. So this particular mineral, it's always green. And oftentimes you will find it with another mineral that is just a stark blue color. So I kind of put those minerals together in your choices so they wouldn't be confusing because they can be together. This one happens to be just the particular one that's green. It's a carbonate, which is very common. Carbonates typically form in marine settings, but not always. And this one has a streak that is a color of green. So if you could streak this, you would see that. It's really cool. And it is a green color almost exclusively. So that makes this color important for identifying this particular mineral. And it's common, super common. And so vitreous to adamantine, and then you get a 3.5 to a 4.0 in its hardness. So it will not be scratched by the penny, but both by the nail, steel nail, and the glass plate would be harder than this particular mineral. Fortunately, though, it is not going to react to acid. It is used as a minor ore of copper, if there's some in it. Really, another mineral called bauxite is where we get something called aluminum, but copper can be associated with this type of mineral. So that's 13. All right, let's move on to 14. You're like, well, that looks a lot like one I just saw a few minutes ago. Yep, but it's a different one. So this particular mineral is special. Not that any aren't, they are. But this one can be special because it can be a very, very priceless mineral. Very few are of that quality, and this one certainly is not. But I wanted to show you what they look like in matrix, meaning of a rock or set, in this case, an igneous rock. And then you can see what the individual crystals look like. So it's a boron, and that's one reason it's special, and it streaks a white color even though it's black. And I promise you it does, because I have some personally in the classroom. Typically comes in a black color, but the ones that are of value for gemstones are brilliant colors of rainbows. And so they're beautiful gemstones when you see them. It has a vitreous luster, and it's a 7 to a 7.5, so it's much like quartz. Does not react to acid. But this one is somewhat common, but not as common as the other black one you had a few minutes ago. All right, let's move on to 15. So you're looking at the greenish color here, and this is a silicate mineral. It is going to strike a clear color, so colorless, even though it's like really kind of a limey green. Sometimes it can be a little yellow. So the black you see is something else, but it's often associated with igneous rocks that are mafic and ultramafic when you learn about that. So it's vitreous, and it has a 6 to a 7 on the Mohs hardness scale. So not quite probably as hard as most quartz, harder than something like apatite, but definitely like the orthoclase, which are the feldspars that we'll be looking at in class here shortly. It does not react to acid. Okay, so some of these can be gemstone. If you are an August birthday, this is your birthstone. And you're like, well, I thought that was peridot. This is a form of peridot. And so its color kind of gives its name away on your list. All right. So there are 2 types of feldspars in your lab. There is a pink one, pinkish red, which is this one. And then there is a white grayish one. So one is pink, one is whitish gray. Go back to your book and look at it. These are super common in igneous rocks. Matter of fact, most everything, because these weather down into clays and make mini sedimentary rocks. But the pink is what makes pink granite. So pink granite has an abundance of this, and the pinker or redder it appears, the more that this particular feldspar will be. So it's got a 50-50 shot. Check it out and do your homework in the book, and you'll figure out which one's the pinky color and which one is the whitish gray kind of color. This definitely has a vitreous luster, and it is 6 to 6.5 on the Mohs hardness scale. So it's kind of similar in hardness to your porcelain street plates. Not a surprise because those are made out of clay. So this stuff makes clay when it weathers out of igneous rocks. Will not react to acid, and very, very common mineral. So feldspars are like the most common mineral in the Earth's crust, and it's a form of orthoclase, just so you know. All right, let's look at 17. When you look at 17, that's another one of these black minerals. It's more stubby than the other two that we looked at. It has no gemstone quality per se, not like one that you just saw a few minutes ago. It's a silicate. Has a 5.5 to 6 on the Mohs hardness scale, and it streaks a white to a gray, sometimes even a pale green. The reason being is that this is considered a mafic and somewhat ultramafic mineral, meaning it's found in those types of igneous rocks, but super common mineral. So you may see this. You're like, it looks like there's 2 other minerals that look like that. Yep, that's part of the message as you do this lab. Lots of minerals look like each other. You've got to know their hardness, their streak color. Typically, you'd look at specific gravity, their crystal form. Some of that's beyond the level of this class. But with the information I've given you, it's a sure thing you can get this one right. All right, let's move on to 18. Oh, wow, look at that. You're like, well, that's got to be something green. Well, it comes in lots of different colors. So it's a carbonate. You've had several carbonates thus far, and it streaks a white color, not green. And it is in every color under the rainbow. So this green color does you absolutely no good to tell you what it is. But what it does is its hardness and a special property. It has hardness of 3. It's one of those reference minerals on the Mohs hardness scale, and it is the only one that reacts to acid. So you should be able to tell me right away what that mineral is. Yep, you've got it if you remember what reacts to acid. If not, look in your chapter. It tells you. Okay. All right, let's move on to 19. This is one where the old olfactory test is important. Smell. And this is a native element, often associated with volcanism, sometimes even with geysers and fumaroles, but thermal features type of thing. And it streaks a yellow color, even if the color that you see is more of a green to brownish color. This is a very good piece of it. Actually, the one you're looking at is probably a good foot tall. It's actually a lot bigger than it looks in here. I didn't put a scale to it. And one thing about this mineral is it's kind of resinous and greasy. And if you touch this, I know I have it in my classroom. It definitely is. It is a very soft mineral, 1.5 to 2.5. That means a penny should scratch it, and your fingernail should as well. Won't react to acid, but it stinks like a rotten egg. So I bet you can guess right off the bat what that one is. All right, let's move on to number 20. Oh, what's this thing? Well, it doesn't look like anything special. Well, it's very super common, okay? Let's start with it's a silicate. It is also going to have a colorless streak, has a Mohs hardness of 7, making it a very important reference mineral, and it comes in just about every color. So you might have a smoky crystal of this, you might have a clear crystal of this, or you might have this version of it that doesn't share the same beautiful crystalline form that this mineral can come in. So this is often what you see in granite that makes a lot of white. This is how it looks. So lots of people are like, I don't think that's what it is. Well, it is. So what's a 7 on the Mohs hardness scale? It will not react to acid. So that rules out calcite. Every one of your testing things for hardness are softer than this, so it'll scratch all of them. Moving on to 21. All right, let's go back and think about the pink version I showed you earlier of a feldspar. This is the other one. This has kind of a grayish, whitish color. So there's a potassium feldspar and a plagioclase feldspar. Which one am I dealing with? You have to go back to your book. Both of them have about a 6 and a 6.5. They both have this vitreous to pearly on the cleave bases, and cleavage refers to how things break apart into layers. where fracture represents if it breaks rough edges. So everything's got some form of that. So when we look at it, this is distinctly one of the orthoclases. So which feldspar do we have? You get to be the judge. All right, let's move into 22. This one has about a 2.5, maybe a little harder on the Mohs hardness scale to maybe a 3.5. But this formation that it makes is super common, especially in desert, dry environments. It's a sulfate. It streaks a white color, even though it looks like this. So it's kind of a cool mineral because it grows in these shapes. It's not like there's some mold it gets into and it pops out this way. And it doesn't have to be this color. It can come in a variety of colors. It does not react to acid. So when you did your homework, which one of them looked like this? As a matter of fact, in the geology.com, they had a picture very similar to this. So it should tell you what it is. Move into 23. First thing I would point out is that this is an oxide. Oxides rust, or at least this one does. Has a reddish to a reddish brown and can even have a silver color. Do you see the red right in there? And there's red even in that kind of metallic stuff. This one might actually hold or at least stick to a magnet because there's some iron that's in it. Has a metallic luster, no surprise there. You can see it with your own eyes. Has a hardness of 5 to 6.5. Does not react to acid, and it is an ore of iron. Ores are basically your metals, and it can be considered a minor gemstone. So I showed you a sample of it when we started this lab as I was introducing you into streak. That is also a version of this particular mineral. So this is what rust. And if you go to the southwest and you see all these red rocks, that's what a lot of that is rusting from, is this particular mineral right here. All right, wow, beautiful, right? So this mineral is about the size of your hand. This sample, anyway, it's a big sample. But even if you had one that was about an inch or two, let's see, an inch by an inch, it would be extremely dense. It has a very high specific gravity. It is also an ore, but this one won't hold a magnet, and it seems like it should. I mean, it's such a beautiful mineral. It is a sulfide, and it is a lead gray to black in color when it streaks, so it actually does have a streak color. It has a metallic luster, and it's a 2.5 on the Mohs hardness scale. I just told you it had a high specific gravity, which means it's dense, but it's pretty soft. Give you another mineral that does that. Gold. Gold is pretty dense, but it's very soft. Platinum is dense and very hard on the Mohs hardness scale. So it's had very high specific gravity, and it's probably the best mineral to make a ring out of because it's so durable. But don't put a band with it, like a wedding band that's made out of gold, let's say white gold with platinum, because the platinum will ruin the gold over time. Can't react to acid. And it's super, super dense because it is a very high specific gravity. Oh, that means we're at sample 25. Yes, we're almost done. Yay. All right, so this is my own personal sample. This one's about 1.5 feet tall in the classroom. And there's a story about where I got this thing. And I've got some magnets that are pretty rare earth magnets sticking to it with no problem, right? You can see that. And it's definitely a metallic color, just so you know. It's an oxide, and it streaks black. It streaked this thing against a streak plate, even though it's super heavy, and it did exactly that. And so its colors come in a black to silvery gray, which this one totally fits the bill on that. And it has a metallic luster to a submetallic, totally in check again. And it is a 5 to a 6.5 on the Mohs hardness scale. And guess what? No reaction to acid, but a magnet, you can barely get off of it. That should be a dead giveaway of what we got here. An awesome sample of it. Just awesome sampling. So these rocks, or minerals, they're not rocks, they're really minerals. They're highly magnetized. All right. So as we conclude each of these labs, I give you a clue. And the reason is sometimes I get questions that are answered in these labs, and I can tell if people have watched it or not. So I asked some questions about different parts of the video, and this one has a little Smokey the Bear doll and one of my painted rocks there. No significance to either one. They're just kind of cool, and putting things like this different in every single one of these little videos to try to help me understand that you've watched the videos, that you understand how to work it. So in summary, what happens now? If you didn't quite get it all, you can go back and watch one of the samples that you might have missed, and you can also get your lab form filled out. And this is important. By now, you're used to uploading those lab forms when they're due to the lab form assignment tool, which is the first item in the lab folders. You also are going to use your lab form to take a corresponding lab assessment. You have 2 tries, just like you have for labs 1, 2, and 3. And so if you missed a sample, you can give it another shot. And then you get those 2 tries, and that's due Saturday by 11:55 p.m., both attempts and the lab form uploaded to the lab assignment tool.